Good afternoon, everyone. So, as some of you might know, I'm not Ilya. So, unfortunately, he was unable to present, so I'm just talking on his behalf. And I'm continuing the talk about the debuggers, but this time we are not talking about the precision of the debug info, but we are talking about the debugging experience. So as some of you might know, the debugging of large programs could be quite frustrating, especially these days when IDEs are, well, pretty smart, so they can show you the values of lots of variables out there. Plus, you might have some custom formatters. You could have some summary providers, et cetera, like what you can see on the slide. So, and as a result, typically, when you try to debug something, lots of different expressions have to be evaluated. And as a result, overall, step into could be quite slow, again, because there are many expressions that are to be evaluated. Still, it looks like that the majority of these expressions are pretty small and simple. So, and then the question is if it could be evaluated in faster or some simpler way. And as Ted already said, it's open source. So we tried to figure out what is already done here. So how can we speed up the debugging itself? And it turned out that 3 years ago, Google Fox presented lldb-eval here at the LLVM Developers Conference. So, and lldb-eval, for those who are not aware of, it's a very fast C++ interpreter for the small and limited language subset. So it comes with its own C++ parser, and in short, it can handle some arithmetics, casts, limited templates, really the useful subset of the language that you normally use for the expressions. So, and it relies on the debug information retrieved over the LLDB API. But, well, because it was developed for the Stadia project, and as you might know, the Stadia is not active anymore, essentially it's not updated these days. Plus, it was designed as a library, so to be used directly from the IDE, meaning that you cannot just take the lldb-eval and use it in your VS Code or whatever. What we did, so we tried to, first of all, revamp the project. So we rebased it on the LLVM top of the tree. Plus, we integrated it into the LLDB proper, so that it could be automatically used in conditional breakpoints, in some values from expressions, and essentially as the first step in the explicit expression evaluation. And if for some reason, well, because the expression is pretty complex, lldb-eval cannot produce the value itself, so we just fall back to the full and precise expression evaluation from LLDB itself. So, and it turned out that this approach worked pretty well. One example is that we enabled custom type formatters in one large game engine. So, and as a result, debugging of, well, one game using that game engine, the overall time required to show essentially all the variables in the IDE. So, and that essentially the step over reduced more than 10 times, 100 times, from 2 seconds down to 100 milliseconds. Plus, the overhead of this two-pass evaluation is pretty negligible. Another case is the evaluation of conditional breakpoints. So here you can see the example. When they put the condition that the breakpoint only fires on every 5,000th iteration, and the time until breakpoint is triggered reduced more than twofold here. And essentially, if you can look, then you could see that the overall time for the expression evaluation itself reduced from 12 seconds down to just 1 second. Overall, it looks like the approach is quite viable. So we can see that this twofold, two-step expression evaluation could be used. Speed up definitely depends on the how many expressions you have and the size of the debug info. Here is the code. Currently, it's just in the downstream fork, and I think we open for the discussions. Should we do something similar to this by default in LLDB, or what could be the other approaches to speed up the debugging experience? Thank you.